Hello, I'm Pete Starkey at Real Time with IPC in San Diego, here at the booth of Berkeley, North America, and delighted to meet with Thomas Kuntz from Schmoll, Dennis Push from Schmoll, Jesse Session from Taiyo America. We're really here initially to talk about the cooperation that has happened over the last year between Schmoll and Taiyo. There has been a cooperative development program for a new generation of solder mask inks, where Schmoll have very generously provided the equipment to assist Taiyo in their development work. Jesse, perhaps you could give us some overview of the outcome of this cooperative development program?
Yes, having the cooperation, the partnership with Schmoll and being able to use their machine has actually sped up our development process. We were able to basically make the solder mask more tuned to the wavelengths on their machine. It was a fantastic opportunity to do the testing in-house and make any changes very quickly.
From your point of view as a technical specialist in solder resist technology, do you see major differences in requirement between the Asian market and the North American market?
Yes, we do. The Asian market, a lot of it is geared towards consumer electronics, so it's really quick turn business. And so everything is dependent upon speed. In the United States, there's a lot of prototyping. So here, everybody's looking at fine precision when it comes to the solder mask. So that's probably the biggest difference between the two markets.
So would you use the same formulation for both ends, or do you formulate separately for these two sectors?
Both. Our goal is always to use the same product for all sectors. But in specialty applications, we will gear a product towards the actual market needs.
Thomas, may I refer to I have known of Schmoll many years ago. I was a user of your drilling equipment in the old days when I actually made printed circuit boards for a living. But you've come a long way since then. Your original identity was in drilling and routing machines, but you have machines at virtually every stage now of the PCB manufacturing process. And you have built a reputation for precision, I think, and precision, registration. Could you give us some sort of comment on how Schmoll has moved along the path of development?
Basically, there's two driving factors that put us into this situation. Number one is that we see us not as a drilling machine company, we see us as a registration machine company. And this includes drilling, of course, and routing more and more, and laser, and finally the eye. The second driving factor was that we are engaged in Bacher since a long time. And Bacher was producing conventional equipment, as many people know, I believe. And when this conventional equipment had the end of the life cycle, we had to do something new, and it was very clear that due to the characteristics of such machine, this could not be done by the Bacher engineers. It's a completely different way, more software, more this. And so we decided to make the next step within the group of Schmoll engineers, and we have separated a department to just concentrate on this, because you cannot mix it up. But this is how we got to where we are today.
I was in Salzburg in Austria 2 weeks ago at the conference of the European Institute of Printed Circuits, and Stefan Kuntz gave a very good presentation which really highlighted, you said you're a registration company. He talked about, again, registration at every stage of the process, and how the tolerance chain, because there can be quite a phenomenal tolerance chain in registration through the manufacturing process, but how that chain could be managed and how that chain could be minimised. And that was a very interesting presentation to listen to. I was well impressed. We're standing in front of your MDI machine, your micromirror direct imaging machine. Perhaps I can ask Dennis, could you give us a brief description of the way this machine works, what its capability is?
Yes, the machine is based on all the experience that Schmoll has from drilling and routing machines. So we do have a granite basis. We do have fast linear motion. This is basically to guarantee a highly precision machine. And we are using a light engine with multiple wavelengths.
Yeah. The benefit of multiple wavelengths is really the versatility of the machine. In that this machine will really image any photoimageable material, I would presume. But certainly, I think from the point of view of the solar resist supplier, whereas in the early days of direct imaging, where there was a single wavelength laser source, it was necessary for the formulator to formulate his photoinitiator system to match the available wavelength. And I'm sure that Jesse has some experience of that situation.
Absolutely.
But now you have this multiple wavelength capability. Really, you can tune your imaging system to suit whatever photoinitiator system is offered.
Yes.
Can you comment on that?
Yeah, it gives us a very right range of spectrum that we can use,
yeah.
And a high flexibility to work with different types of materials.
Yeah, yeah. If we look at the solar resists that have been the subject of this development program, what sort of speed are we able to achieve with the MDI system? What sort of resolution are we able to achieve with the MDI system?
This really depends on the machine configuration itself.
Yep.
So the machine can be equipped with one light engine, or can be upgraded up to a multiple head system, and this will decrease the exposure speed, but also the effect of the 4 different wavelengths gives us the power available to process at very high speed.
Yeah. But basically, it's a scalable system, as it turns out.
Yeah, the scalability is one thing, but why we work together with Taiyo is that we realized that the standard inks were very slow and not adapted to this new kind of wavelength system.
Yeah.
And to take advantage of this, of the spectrum between 405 and 365, we wanted them to improve let's say, the traditional kind of ink.
Yeah.
And when we talked last year on this show, we said, okay, but to do it right, we really need to have a multiple amount of tests, because you do a little bit here, you do a little bit there, and you have to find, and then you have to put it back to the customer to see in the further process whether this really comes back to surfaces and all of this stuff. So this gives speed then with a requested quality, and this is a big factor. Just to throw some figures, we have about 20 customers in the market, and after they change to this, what we would call, maybe it's not right, DI inks.
That's correct.
You could, in average, halfen the time with this, and I've seen also inks that even do less. They may have some, let's say, single-minded characteristics, so you can go lower, but if you want to have a broad bandwidth of application, then I think it's about half that you can achieve.
Yes.
But as an outsider, it's very encouraging to see what can be achieved by cooperation. You could achieve certain things in isolation. You have a lot of engineering resources. Taiyo could achieve a lot of things in isolation. They have a lot of formulation resources. But to have this sort of direct exchange and this direct cooperation, one gives it speeds the development program, but at the other end, you know that both ends of both the hardware and the material are optimized to each other.
It's not only a question of optimization, it's also a question of trust from customer side.
Yeah.
Because when they know, this technology has met the specifications of the ink,
Yeah.
then they have a bigger trust to say, okay, this is going to work.
Yeah.
Of course, we still have to see what is the special application of the customer. This may vary a little bit, but there's a basic foundation.
Yeah.
And we have seen it very often that customer come with some ink, hey, please do it. And this sometimes works,
Yeah.
but sometimes doesn't.
Yeah. Yeah.
And this is pretty important to
Yeah.
know. And for this reason, we said, just as Taiyo is a major supplier in the US, just let's define something which would work for sure well.
Yeah.
And the customer can say, not only I'm buying a machine, I'm buying a system.
Yeah. Yeah.
And
yeah.
I think this was the idea of our common project, that the customer feels secure, and if he got this kind of task to do,
Yeah.
he knows what he's going to get.
Yeah. Yes, I understand exactly what you say. Having I say, in a previous generation, been the user on the other end, the user that's got to make sure that the hardware works with the material.
Yes.
But to know that because of cooperation further up the line, things have already been proven.
So I think you always have to consider that the same happens, of course, with drilling machines. But we can drill holes in our factory and inspect them very easily. In exposure, it's completely different. You need to have the right material to coat, you have to have the right developing equipment, so this is pretty difficult for us.
Yeah.
For this reason, the process to get a right result is much more longer and also not predictable.
Yeah. Yeah.
And for this reason, it was a good way to put this together. And
Yeah.
we had to send the machine to US anyway for this show, so we decided to send it 6 months more early.
Yeah.
And so this didn't hurt us a lot, and they had a good benefit, and
Yeah.
we of course too.
It's very much a win-win situation. Just turning to the machine itself, Thomas. I see a machine with a single panel on the platform. Is there any scope for the future to make this an automated process?
Well, first of all, we have a tandem machine.
Yeah.
This means you can exchange this to a much bigger platform which has 2 tables, so you can load and unload
Yeah.
while the machine
Yeah.
is working. And both of the machines also have automated systems, so
Yeah.
we have done this already for the market.
Yeah.
Not in the US, but in Europe.
Yeah.
So both systems are available with automation. Of course, it has to be looked at,
Yeah.
panel size
Yeah.
and all of this stuff.
Yeah.
But in general, of course, they are available.
Yeah.
On the other hand, we see that our current market very much is dominated by customers who want to be very flexible.
Yes.
Inner layer, outer layer, solder mask, and smaller size customers that really like the size of the machine
yeah.
towards the flexibility that they
Yeah.
get. So automation comes into the game if you want
Yeah.
to have more mass production.
Yeah.
But this is not typically our customer base in this kind of
Yes.
market.
But from what you've explained, really you have a system that is very broadly scalable, flexible, adaptable. You can start with the most basic system. You can scale up the capacity of that system. You can automate the capacity of that system. You can adapt it to specific requirements, or you can just make it a very versatile system that can really handle any particular task that you offer to it.
Yes.
This has been a very interesting conversation. I'm delighted to have had the opportunity to talk to you guys. Is there anything else that you believe that we ought to discuss while we have the opportunity?
Well, we see that this market will further develop in the future.
Yeah.
Tighter tolerances.
Yeah.
Future systems may have even better resolution.
Yeah.
This already has got a good resolution, but we see a trend
Yeah.
towards this. But we also see if you do this, you also have to change other equipment in the process.
Yeah.
So, but we see a trend for this, and people are interested in that. And of course, we are working on that as well.
Of course.
So, step by step.
Yeah.
Our goal is not to be, let's say, the biggest contender in this market. We would like to gain experience with registration, combine it with our line of other registration products and understand what the customer is being driven by demands of the market, and this is our general goal. So,
okay. Well, gentlemen, thank you. Thomas, thank you. Dennis, thank you. Jesse, thank you.
okay, welcome.
Pete Starkey, Real Time with IPC. Thank you.